All right. Hey folks, welcome to the next class in the series of Basics to Advanced, where we are going to do percentages PYQ questions in the last part of this topic. So we have done some basic part and then we have solved some intermediate level questions. Now it is time to see what type of questions where you get pure percentage questions. Now we need to understand that any question that you get on profit and loss or SICI is also a percentage question. So which will be doing it when we do those topics. But you also get standalone percentage questions, which is not common. There is no surety that you get a standalone percentage question, but then there have been instances where we have gotten that. So we're going to poke around a few questions here and see how to solve them. So without any further ado, let's solve our questions. Same template. I'm going to give you a minute to take a screenshot or solve it. And here we go. So look at the first question over here. Identical chocolate pieces are sold in boxes of two sizes, small and large. The large box is sold for twice the price of the small box. If the selling price per gram of chocolate in the large box is 12% lesser than the small box, then the percentage by which the weight of chocolate in large box exceeds that in the small box. So all the chocolate pieces are identical in size, but the number of pieces that goes inside a box matters. So the large box, obviously since it's called large, will have more number of pieces. The smaller box will have lesser number of pieces. Automatically the weights will also vary. So the weight varies, the price also varies. So there is a pricing point here. So the first thing that's given us, the large box is sold for twice the price of the small box. So I'm going to say the number of pieces in the box is going to be L. I'm going to say L pieces are there in the large box and then S pieces are there in the small box. That's the total weight, right? Now I can say here selling price of large box is equal to, if I call it 2x, selling price of small box will be x. Now the selling price per gram of chocolate in the large box is 12%. We know that there are L pieces in the large box, S pieces in the small box. So the selling price per gram of chocolate in the large box is 12% lesser than the small box. So what is the selling price per gram of chocolate? That will be your selling price divided by number of chocolates, right? That will give you per piece, per gram. So I can say 2x divided by L will be the selling price per gram of chocolate from the large box. What will it be for the small box? That will be x divided by S. It is said that the large is 12% lesser than the small, which is 88% of the value. So this will be equal to 88 by 100. So we can simplify this. X and x gets cancelled. 88 and 100 goes well in 22 times and 25 times. This goes well 11 times. So you'll have 1 by L is equal to 11 by 25 S. Or from here we can say 25S is equal to 11L, or S is to L is equal to 11 is to 25. Which is telling me that if there are 11 pieces in the small box, there are 25 pieces in the large box. We have the ratio of number of pieces per box. So the question is, then the percentage by which the weight of the chocolate in the large box exceeds that in the small box is nearest to. So the number of pieces and the weights are proportionate because all pieces are of the same size. So if there are 11 and 25, the gap is 14 from 11 into 100. That will be 14 by 11 can be written as 3 by 11 into 100. 3 by 11 is 27.27. So 1.27.27 into 100. That will be 127.27 percentage. There's not a second dot here. 1.2727. 127.27 percentage. Look at my options. Do I have that? Option A is there. That's our answer. Nice idea. Fix your variables. Ensure that you don't get confused by what data is given. The moment you get all of them on track and you put it on a paper, it flies. Right. We'll move on to the next question. And here we solve. A box has 450 balls, each either white or black. There are being as many metallic white balls as metallic black balls. So the number of white metallic balls is equal to number of black metallic balls. 40% of the white balls and 50% of the black balls are metallic. Then the number of non-metallic balls in the boxes. So I happen to have 450 balls here. Some of them are black, some of them are white. Right. And then the data also says 40% of the white balls and 50% of the black balls are metallic. The number of white metallic and black metallic balls are equal. So I can say 0.4 W is equal to 0.5 B. Can say this 40% of white balls, 50% of black balls we have. We can equate that. Or from here, W is to B is equal to 5:4. So if there are 5 white balls, there are 4 black balls. So 9x is equal to 450. X is equal to 50. So black balls will be 200. White balls will be 250. Right? I've taken that. So because it is 4x and 5x by ratio. Now we know 50% of the black balls are metallic. So which means 100 of them are metallic. The number of metallic balls are equal in both colors. So this will also be 100 metallic, which means 100 non-metallic are there. 150 non-metallic are there. So the number of non-metallic balls, non-metallic will be 100 plus 150. 250 balls are there, and that will be our answer. Simple question. Nothing fancy here. The statement might be a little tricky for us to infer, but then if you know how to read a question, if you know to pick your data, we fly. Right? We'll hop on to the next question now. I'm going to step aside. And here we solve. The total of male and female populations in a city increases by 25% from 1970 to 1980. During the same period, the male population increased by 40%, while the female population increased by 20%. From 1980 to 1990, female population increased by 25%. Okay. In 1990, if the female population is twice the male population, then the percentage increase in the total male and female populations in the city from 1970 to 1990. Too much data. Way too many stuff given. But then by reading the question, I understand that looking at two different cases. 70 to 80, there's a change. 80 to 90, there's a change. They are asking 70 to 90, what is the net change? We'll do that. So in 1970, the number of men and the number of women. So I'll take them to be men and women. Let me call it M and W. So in 1980, what has happened? The total, we'll also take the total here. We'll also take the total. The total population increased by 25%. So the total population here is M plus W increased by 25%. That will be 1.25 M plus W. Right. I'll write it a little top in case if there is something else that I need to write, I need that space. So 1.25 into M plus W. Here it will be M plus W. Right. What happened during the same period from 70 to 80? Male population increased by 40%. So whatever men that we had went up by 40%, 1.4 m. Female population went up by 20%, 1.2 m. From here I can understand that 1.4 m plus 1.2 w is equal to this. Male plus female population is the total population. So we can equate this. I'm going to write 1.4 m plus 1.2 w is equal to 1.25 m plus 1.25 w. So this goes there, this comes here. 0.15 m is equal to 0.05 w, or 3 m is equal to w. Women, okay, that's male and female, men and women, not a real difference here. So 3 m equal to w. So wherever I have w, I can rewrite that to be 3 m. So I'm going to take this w is equal to 3 m. If this is 3 m, m plus 3 m will become 4 m here. So this would become, w will become 3 m. So 1.2 into 3, this will become 3.6 m. I can also use this over here. So 4 m into 1.25, this will become, right, we have this. We'll wait. What else is given? In 1990, if the population is twice the male population, or something is before that, from 80 to 90, the female population increased by 25%. So whatever female population we have, this has gone up by 25%. So what is 25% of this value? 3.6. 25% is 0.9. So this will be 4.5 m. What else is given? In 1990, the female population is twice the male population. Whatever value here it was, this is twice of that. So this should be half of 4.5. This will be 2.25 m. So 2.25, this will be 6.75 m. What is the question? Now we have all the data that we need and everything is written with respect to m. So any ratio that they ask, it is doable. We can figure it out. What is the question asked? It is saying then the percentage increase in the total male and female populations from 70 to 90. So from here to here. So it is an increase of 2.75 from 4 into 100. So 2.75, I can write it as 2 3 by 4, which will make it 11 by 4. This I can cancel it 25 times. So into 25. So that's 275 by 4. 240, 60 times. All of them are in 60. And then you have 35, 8 times. 38. 3 options are there. So remainder 3. So 68.75. Do we have that in the options? Yes. Answer option A. Nice, neat question. Plug in your data, figure out what change happens where. The moment you plot it, such a beautiful question to go for. Right? The next one then. I'm going to step aside once again and let's solve. In an election, there were 4 candidates. 80% of the registered voters casted their votes. One of the candidates received 30% of the casted votes, while the other 3 candidates received the remaining casted votes in the proportion 1:2:3. The winner of the election received 2512 votes, more than the candidate with the second highest votes. So the gap between the first and the second happens to be 2512. Then the number of registered voters was, okay, I'm going to go the total number of registered votes, I'm going to say that's 100x. Now, by data, I know that only 80% of the registered voters voted. That means this is 80x, this is 20x, this did not vote. This is vote. Right. What else is given? One of the candidates received 30% of the casted votes. So whatever votes were casted, 30% goes to one guy. 10% is 8. 30% is 24x. Remaining we have 56x. And it is given that the remaining casted votes in the ratio of 1:2:3 for the other 3 candidates. So this is split in the ratio 1:2:3. So I can say 6 parts is equal to 56. 1 part is equal to 56 divided by 6, 28 by 3. So 1 part, this is 28 by 3x, 56 by 3x. This will be 28 into 3 by 3. So this will be 28x only. 84 by 3x, which is 28x. So I notice this guy is roughly 9%. This guy is roughly 18%. This guy is 28%. So this is the first highest. This is the second highest. Now by data we know that the gap between these two buggers happen to be 2512. So I can say 4x is equal to 2512, or x is equal to 2512 divided by 4. 600, 112 is 28 times 628. X is equal to 628. What is the question? The number of registered voters, which will be 100 into 628, 62,800. That's our answer. Another simple question that you can plug in and get it done. Right. We'll hop on to the next question. A fruit seller has stock of mangoes, bananas, and apples with at least one fruit of each type. At the beginning of a day, the number of mangoes make up 40% of his stock. That day, he sells half of the mangoes, 96 bananas, 40% of the apples. At the end of the day, he ends up selling 50% of the fruits, the smallest possible total number of fruits in the stock at the beginning of the days. I don't know what the totals we started with. I want to make it a little convenient. So I'm going to say total is equal to 10x, so that we can avoid a few decimals as much as possible. 40% of the total stock makes up mangoes. So mangoes is 4x. The remaining part is 6x. We'll keep that. He sells half of the mangoes, which is 2x is being sold. And then 96 bananas. I don't know how many bananas are there. I'm going to say we have y bananas. So apples will make 6x minus y. How is that? 4x mangoes, remaining is 6x, out of which y is bananas. 6x minus y is going to be your apples. So this is apples. 96 bananas are sold, and 40% of this value is 0.4 into 6x minus y. This is what he totally sells. He ends up selling 50% of the fruits. The total is 10x, so he sells. So we'll solve for this equation. We'll have 2x plus 96 plus 2.4x minus 0.4y is equal to 5x. 2 plus 2.4 is 4.4, goes over there, becomes 0.6. So 0.6x is equal to 96 minus 0.4y. I'm not bringing y here because you're looking for x. Divide this entire, multiply this entire equation by 5. You will get 3x is equal to 480 minus 2y, or x is equal to, divide this entire equation by 3. 480 by 3 is 160 minus 2 by 3y. Now we know that y is the number of bananas. So the first thing that I can say is y is an integer. Now x 2x, I cannot have x to be a decimal, because if you put x as a decimal, 2x bananas were sold, it will become decimal. So x cannot be a decimal, x has to be an integer. For that, y should be an integer. Y very specifically is a multiple of 3, because then only this 3 and y will get cancelled. This part is an integer, this part is an integer. So I can say y is a multiple of 3. But I am looking for x minimum, right? X minimum happens when 160 minus 2/3 of y maximum is plugged in. Only when y goes up, x comes down. I need y maximum. What is the maximum value of y that I can put? Y needs to be minimum 96. Why? Number of bananas that has been sold is 96. We had at least one fruit of each type, right? So, and the minimum value of bananas is 96. So y is definitely greater than or equal to 96. But is it lesser than or equal to some value? Now I am wondering, if I put y is equal to 96 here, this case I understand that we have to ensure that for some value of y, this is also greater than 1. What do I mean by that? 6x minus y. So substitute the value of x that we have here. We'll get 6 into 160 minus 2 by 3y minus y. Right? So if I multiply this in, I'll have 960 minus, this will become, what will this happen? 12 by 3, 4y minus y minus 5y. This is the number of apples, right? Now if I put for some value of y, this thing becomes 0, or 5y equal to 960, y is equal to, divide this 192. So if I put y equal to 192, number of apples becomes 0. Can't happen. Which means y maximum value is 192. Can't go beyond it. Can't be 192. Has to be less than 192. Has to be a multiple of 3 less than 192. 192 itself is a multiple of 3. So the immediate value of y that I can look for is 189, which is a multiple of 3, which is an integer, less than 192, satisfies every condition that we need. So plug in this equation now. So x min is equal to 160 minus 2 by 3 into 189. Cancel it out. This is 63 times 63 into 2 is 126. X is equal to 160 minus 126. X is equal to 34. Plug in x equal to 34 in this equation. So 10 into 34, 340 fruits were there at the beginning of the day, and that is our answer. Nice and easy question. It's a lengthy one, undoubtedly. But then if you know where to apply your variables, how to take them through, it's a question that is definitely there on the cards for you to solve. So solve them. These are all samples of CAT PYQs, not samples. They happen to be PYQs from CAT. So you understand how important it is to hang on to your basics, because sometimes there are questions that come from the basic level, not even intermediate, utter basic level. So crack them, get them, practice them. If you have any questions, if you are looking to have conversations, ask questions, have discussions, build healthy peer groups, scan the QR codes that will take you to the groups that you need to go in. If you are already a part of the group, practice your questions properly, practice your topics. Best wishes.